So in this course, we are going to learn a little bit about complex numbers. Okay, first point is that complex numbers are very easy. It's not at all complex. Okay, and the most important thing to understand in complex numbers is to try not to understand it. Okay, the biggest mistake when I started learning complex numbers, my big problem was that I tried to understand why this root of -1 is I. You might have heard about imaginary numbers. Now, one of the first things that you learn is when you try to do root of -1, it's not possible. Whereas root of 4, you call it 2, right? And so if I say x square is 9, I know that x is plus or minus root 9, which is plus or minus 3. Whenever, first thing to keep in mind, whenever you say root of, it's always a positive root, okay, for real numbers. So root of 9 basically means 3. That's why we put a plus or minus, so it's plus or minus 3. But you have also probably learned that root of negative numbers is not possible, right? That's the first thing that you learn. And then suddenly when you're introduced to complex numbers, the first thing you learn is root of -1, we will going to call it I. Now what does that mean? How does it become I? And so if you're trying to understand where this came from, actually it didn't come from anywhere. There is no reason behind something like this. In fact, the best way to understand complex numbers or imaginary numbers, we call this imaginary, the base for imaginary numbers. Okay, the best way to understand it is to say that you don't understand other things that you think you understand. For example, natural numbers. We say that 5 is a natural number. But what does that mean? Does it mean that it exists in nature? You have 5 fingers. You can have 5 pencils. But if you want to see 5 in nature, you will never be able to find. Sometimes people may say 5 is the number 5. But that is just a representation. That's just a way of saying. It is just like saying I is this number. Means nothing. It's just a symbol. Now, where is 5 in nature? Actually, you will never find it. But you will find 5 fingers. So what is 5? 5 is what is common to this and to these 5 people here by saying that this cancels off with Indu, this with Gomati, this with you, and this with you, and this with you. So no more fingers, nobody here. So that basically is the way to talk about what is 5. 5 is what is common. Another point where probably you are used to doing this and you think you understand it very well. Let's think about this. So if I ask you what is 4 divided by 2, what will you say? 2. What is 9 divided by 3? 3. And suppose I ask you 12 divided by 3? 4. When we learn about division, we learn that 12 is divisible by 3. Suppose I ask you what is 2 divided by 3, first time we learned that it's not possible. Right? And then suddenly one fine day, we decided to call this the answer. What is 2 divided by 3? 2 by 3. What is 4 divided by 6? 2 by 3. Now this at least looks like I'm doing something and getting 2 by 3. If I say 2 divided by 3 is 2 by 3, is that a question or an answer? Suppose I say what is 9 divided by 3 and I tell you 9 by 3, will you accept? No. So you are actually saying write 9 by 3 in the form of something I already knew earlier. You know natural numbers earlier and this is writing it in a newer way. Then you come across, as we keep doing this, we define what we call division operation. Then we come across a new kind of division which you can ask the question but you cannot answer. It's very easy. Once you define, in mathematics you will find, it's very easy to define operations. Like you can define subtraction. If I had 20 objects, take away 5. How much are you left with? 15. So that is a subtraction operation. Now once somebody learns subtraction operation, you can always say, if I have 5 objects and I take away 8, well you can't take away 8. But I can always ask the question, what is 5 minus 8? Now in the beginning in mathematics we learned by saying, no, you can't do it. Then mathematics evolves by saying that is minus 3. Okay, what you couldn't do, you now rename it as what is possible. This was a question. 2 by 3, not possible, question. And it has become the answer. You can't solve the question, you call the question as the answer. Do you understand? That was the first time probably you were doing it consciously. Second time, what is square root of 9? 3. What is square root of 4? 2. What is square root of, let us say, 2? Root 2. Actually, you might like to now say, wait, it's 1.414, but that's an approximation. What is the best answer for square root of 2? Root 2. Now, root of 4 was a question. Root of 9 was a question. Root of 2 should be a question. What is the answer to that question? Root 2. So suddenly question has become the answer. It didn't exist before, and in mathematics the whole point is when you write root 2, when you are creating a new number called root 2. So what is root 2? Root 2 is the number which when squared gives me 2. What is this number in terms of fractions? I already know. In terms of natural numbers, I already know. There is no such answer. Okay. Later we come across how to approximate it. But the basic idea is that this did not exist before. By defining it, you have just created it. Now the same way, we learn that root of -4 does not exist. Root of -9 does not exist. No number squared, no number that we know so far, squared gives me -9. But I can always define now a new number. And that's exactly the starting point of complex numbers. You can't understand it in terms of other things before because it doesn't exist. Can the universe exist without complex numbers? Absolutely. But the universe can exist without real numbers. The universe exists without natural numbers because numbers are themselves not natural. Numbers exist in our heads. Complex numbers exist in our heads. This is an invention. You can't understand it by saying why? That's not at all a useful question. Instead, a better question is, okay, so if I define this, so what? What else can I do with it? Okay, since it's a new thing, we can now define more things with it. Just like root 2 is defined as a new number, what is its property? Root 2 square is 2. Is it useful? Very useful, because then when I get to root 8, I don't have to think about it separately. I will think of it as 4 times 2 and I'll write this as 2 root 2. Root 8 is 2 times root of 2. Whatever this fellow was, it is 2 times that. It gives us convenience to do certain operations, and that is the main reason we are going to study complex numbers. Okay? Don't waste too much time trying to understand what is this I or what is this root of -1. Focus instead on how to use it. Okay, that's basically the main idea. So let us look at the next step. So now that we know what basics of complex numbers, the starting point of imaginary numbers is, let us define some basic rules. Now if you say root of -1, we can keep it as root of -1, but since we need to say something, I'm going to call this I. Does not mean that root of -2 I will call j and root of -3 I will call k, then there's no use, right? So we are going to then say root of, for example, -9 is root of 9 times -1, and then we are going to write this as root 9 into root of -1, and root 9 you know is 3, always plus 3. Okay, root is always positive root. If you have x square is 3, you can say x is plus or minus root 3. The reason you put plus or minus is root itself is only plus. Okay, so root 9 is 3 and root of -1 I. So we will call this 3i. Now you may think you can do this always. Immediately there is a problem. Let us look at, suppose I start with root 9 is root of -9 into -1 is root of -9 into root of -1. Now root of -9 is how much? 3i, because we just calculated. So this is 3i, and what is that? I. So we are going to get 3i square, but what is I square? Because we just defined root of -1 as I, so this means I square is -1. In fact, that is the definition of I. So if I put that, then I'm going to get I square, which is -1. But wait a minute, I started with root of 9, which is 3, and ended with -3. There's a problem, right? So the first rule in complex numbers is never do this. What is never do this? Never do this is when I have root of a into b, you can write it as root of a into root of b only if a is positive or b is positive or both are positive. If one of them is positive, fine. But if both are negative, you are not allowed. Okay? Positive and greater than, well, it could be 0, it doesn't matter. What you can't do is, you cannot say root of negative is, or let's write it as just negative. And when I mean minus, I mean minus negative number. You cannot say is root of negative into root of negative. This splitting is not allowed. This splitting was allowed for positive numbers. So the first rule is that this splitting, that you can separate out root of AB as root A into root B, is possible only if A is positive. So actually think of it this way. You can only take out the positive fellow outside. If the remaining fellow is negative, will remain as negative, no problem. So one of them can be negative. So either, so at least one of these two must be true. Both don't have to be true. You can have, this is true, this is okay. Because here, think of it, what am I doing here? I am not pulling out the root of minus 1, I am leaving it there. So the way I will think of it is, when I do root of minus 9, what I am doing is root of 9 times minus 1. I am not removing that root of minus 1. I am only removing the 9. Which means I am also separating that out. But basically I think of it as, this was already inside the root, I am only pulling out the root of 9, which is 3, and the remaining part is root of minus 1. That just remains as it is. So what can you pull outside when you are pulling out of the root? Only the positive part, which effectively means one of them can be negative, but if both are negative, you can't pull this one out, not allowed. Okay. So now, because it's a new number system, we will have to define new set of rules. Now this is the only complex rule, only rule that is different from what you know. Everything else works exactly like what works for real numbers. For example, if I had multiplication, I can do 3 into 4 and I can say that that is 4 into 3. You can do that with I. So if I had I and then let's say 3 into I, you can call it I into 3. You have 3 times 4 plus 6 is 3 times 4 plus 3 times 6. What kind of law do we call this? This one is called distributive law. Okay, this is called commutative law. A into B into C is A into B into C, or you can treat it as A into B into C. That is called associative law. Similarly for addition. Now whatever you know will work with complex numbers. So 3 into 4 plus I. I have suddenly introduced a new idea called 4 plus I. I'll explain that in a minute. You will find that this is still true. 3 into 4 plus 3 into I. Okay, I'm not going to waste too much time on all of these. The basic idea is pretty much every rule that you already know for regular numbers is also true for imaginary numbers, and we are going to make a combination of real and imaginary, and we are going to call it complex numbers. So it will be true for that also, except this one rule. So if you want to pull A out of a root, not only should it be positive, it should also be real. So obviously if it has to be positive, it has to be real. You can't even pull out a negative number, and therefore you definitely cannot pull out a imaginary number. Not easy. You can find square root of imaginary numbers, but we will worry about that a little later. So is that hopefully clear now? Okay.